So today we have a nice geometrical problem. We have a quarter circle. Now we draw a rectangle inside it in such a way that one corner of the rectangle is the 90-degree corner of this quarter circle. Now we draw a circle inside this diagram such that it is tangent to the base radius of this quarter circle, and also it is tangent to its circumference, plus it is also tangent to the length of this rectangle. Now the question is to find the area of this particular circle when the breadth of the rectangle is 3 units and length of the rectangle is 4 units. So this is Anmol Mishra, and now let us see the solution. How can we find the area of this particular circle? So first of all, we will find the radius of this particular quarter circle. So as per the definition, radius is a line segment running from the center of the circle to its circumference. So over here, if I draw a line segment joining the points A and C, it will ultimately form the radius for this quarter circle because it is from the center and ending on the circumference. Hence AC is the radius of this quarter circle, plus it is the hypotenuse for this particular right angle triangle. This angle is 90 degrees because the quadrilateral ABCD is a rectangle. Okay, so in a rectangle opposite sides are equal. So if this length is 4, so this is also going to be 4, and if this is 3, this is also going to be equals to 3. Okay, now in this particular right angle triangle, by applying the Pythagoras theorem, we can get that hypotenuse, that is the radius of the quarter circle, is 5 units. So let us write it down that we have got radius of the quarter circle is equals to 5 units. Okay, now we will utilize the fact that this particular circle is tangent at these 3 points. So for that, let us mark the center of this circle. Now as per the given data, these 2 points are tangent points. So if I draw the radius to these 2 particular points, the angle formed at the point of contact would be 90 degrees because it's a theorem. Okay, now these 2 lengths would be equal and it would be equals to radius of the red circle, and we don't have it, so let us take it as a variable. Therefore radius of the circle be equals to a variable x. This means these 2 lengths would be equal and it would be equals to x. Okay, now we can see that this angle is 90 degrees because it's corner angle of this particular rectangle, and by linear pair we get that this angle is also 90 degrees. So over here we have a quadrilateral, all the 4 angles are 90 degrees and adjacent sides are equal. This means it is a square. So over here this length would also be equals to x, this would also be equals to x. So let the base be equals to x only because we don't require the other thing. Okay, now we will utilize the fact that the circle is tangent to the circumference of this quarter circle. So we have a very nice theorem that if there is a circle and there's another circle that is tangent to it either internally, or the second case in which we have a circle and another circle is tangent to it externally, the center of the bigger circle, the center of the smaller circle, and the tangent point would be in a straight line. Either the tangential is internally or either it's externally. Again, the center of the circle, the tangent point, and the center of the other circle would be in a straight line. So we are going to utilize the same fact over here. Now over here, this particular point is the tangent point, this is the center of the circle, and this is the center of the quarter circle. So if I draw a line joining these 3 points, it would be a straight line because of this theorem, a circle tangent to other circle internally. Okay, now over here, from here to here, a line segment from the center to the circumference. This means it is the radius for this red circle, and that we have taken as a variable x. So this much length is going to be equals to x, and let this point be equals to p, and let the center be O. Therefore OP is having a length x. Okay, now the complete length of AP is going to be the radius of this quarter circle, center to the circumference. Therefore AP is going to be equals to 5 units because radius of the quarter circle is 5. Now the remaining length, that is AO, is going to be equals to 5 minus x, and this can be done only and only when the points AOP are collinear. This means it's a straight line. Okay, now look in this particular triangle over here, the hypotenuse is AO, so it is going to have a length 5 minus x. Here is the perpendicular and it is having a length x. What can you say about the base? So as base is a straight line, this much length is equals to 3 and the remaining length is equals to x. Therefore the complete length of base becomes 3 plus x. So let me just redraw this triangle over here. The triangle is somewhat like this. Here is the 90 degree, here is x, this length is 5 minus x, and base is going to be 3 plus x. So we can simply apply the Pythagoras theorem. Therefore 5 minus x the complete square equals to 3 plus x the complete square plus x square. Now if I just open the brackets, so 25 plus x square minus 10 times x equals to 9 plus x square plus 6 times x plus x square. Now over here x square and x square got cancelled out, so what we finally have is x square plus 16 times x minus 16 is equals to 0. So over here we have a nice quadratic equation, and to simplify we can simply use the quadratic formula. Therefore x would be equals to negative 16 plus or minus square root of 16 square minus 4 times of negative 16 upon 2. Therefore x would be equals to, now over here we can see that 16 is already negative, and in square root we again have plus or minus. So we cannot take it as a minus because it will form a complete minus, and as x is the radius of a circle, it cannot be negative. So we have to take the square root as a positive square root. Therefore square root of 16 square plus 4 times 16 minus 16 upon 2. Now over here we can see that 16 square plus 4 times 16 is there, so I can simply take 16 common. So 16 taken common, inside the bracket 16 plus 4, and that is going to be equals to 20. So 16 into 20. Now 20 can be written as 2 into 2 into 5, and that's simply 4 into 5. So let me write it as 4 into 5. Okay. Now 16 is a complete square of 4. 4 is a complete square of 2, and 5 isn't. So square root of 5 as it is minus 16 upon 2. Now if we simplify it further, we will get x is equals to 4 square root of 5 minus 8. So here we have got the value for radius of the red circle. Now what we have to find is area. Therefore area is equals to pi times the radius square, so pi x square. Now the value of x we have got is 4 square root of 5 minus 8. Therefore area becomes pi times 4 square root of 5 minus 8, the complete square. This thing would be equals to pi multiplied by 4 square root of 5, the complete square becomes 16 into 5, that's 80, plus 8 square, that is 64, minus 2 times 8 times 4 square root of 5. Now if you will simplify this thing further, you will get area of the red circle equals to pi multiplied by 80 plus 64, that's 144, minus 2 into 8, 16 into 4, 64 times square root of 5. And this thing is equals to area of the red circle, and that's the answer that we were looking for. So this was my way to solve this particular question. If you have any other method other than this, or else if you have any other question that you think I should try, you can email me, or else you can send it to me on my Instagram. The link is in the description.